So if you've ever, yeah, if you were in Honors Algebra 2, you might have seen this, something like this, where they'll make a little table. It's like x, f of x, and then the derivative, and then the second derivative, like that. So with this function, the first thing we need to find is we need to find out where the derivative equals 0. So first you got to find the derivative. That would be equal to 3x squared minus 12. So where's this going to equal 0? I think we're going to have 2 zeros. So let's see, 3, what is that? X squared minus 4. So if we factor that, we should get 3, what is it? X plus 2 minus 2, like that. So that means we have a 0 at -2 and +2. So I'll say when x equals -2 and +2, like that. That's where we get 0 for f of x. So then what we have to do is say, okay, what happens here? Let's just say, let's take -3 to the left side. Let's say 1 and then 3. We want to see what happens. So because we know f of x is 0 at -2, we know this is a critical point. So I'll write CP, critical point. We don't know if it's a max or min yet. But let's put in -3 for the derivative. So we get this 3, -3 squared minus 12. So it'll be 9 times 3 minus 12. That's 27 minus 12. What would that be? 25, 15? I think I did that right. So then we get a positive number. So we have a positive number here. And then if we put in 1 equals 3, 1 squared minus 12. We get 3 minus 12. That gives us -9. We got a negative number there. And then I'll do it again. I'll do f of prime 3 equals 3 squared minus 12. And that's just going to be the same thing. I'll get 15 again. So that's positive. So if you notice, I'm going from positive to negative to positive again, which means that my graph is doing this. It's positive, it's going up, negative is going down, positive going up. And then because I know it goes up, down, up, this is a max and this is a min. Because it goes up, down, up like that. Now for our second derivative. All right, let's do -3. So our second derivative at -3. First, the second derivative would be, start from here. It would just be 6x. So this equals 6x. So let's put in -3. If I put in -3, this gives me -18. So that's negative. And then if I put in -2, 6, -2, that gives me -12. That's still negative. Let's put in 1. put in 1 here. 6 times 1 gives me 6. That's positive. Put in 2 there, I'll get a positive number, positive, which means I know where it's concave down and concave up. Which means from here, it's going to go like that. And here it's going to go like that, up like that. And if I wanted to find my inflection point, I would say, okay, I have 6x equals 0. Our derivative, or second derivative, equals 0. So obviously 6x equals 0, x equals 0. And if we look at our graph here, that's where our inflection point is, right here, for x equals 0.